Section 1, set the scene by giving you a general understanding of maths. In some of those lessons, I showed you how to use some management and psychological techniques. When you apply these consistently, you will find that your efforts in the subject are more efficient and you make better progress. I will now extend your management techniques. This will make all maths problems easier. In an earlier lesson, a carpenter said he calculates his bill when building a fence on the basis of $250 plus $100 for each section. We looked at the question, how long a fence can I get for $950? This is type 2 maths because it involves an unknown, the relevant length. We can represent what's happening by an equation and then solve it. That equation is 250 plus the missing information is $950. So the missing information is 700. Now what we have to ask ourselves is 700 what? It's actually $700. We started with $250 to $950, so therefore $700. What is the relevance of that $700? It is the money devoted to the length of the fence. So the 700 was the cost of the fence sections and not actually what we want to know. So we converted it by doing another calculation. It was 700 is a missing quantity times 100. $700, $100. So that means the missing quantity is 7. And what is the relevance of that 7? That's how many $100 sections we could get for the $700 directed towards the cost of the length of the fence. So it's another number that's relevant to our scenario, but it's still not the answer to the question, how long a fence can I get for $950? 7 is the number of fence sections, so we must convert that again. And in the original problem, each section was 2 meters long, so therefore the 7 sections converts to 14 meters of length. That now is the value that the original question required. So there's a logical link between what we want to know, total length, and what we calculated on the way, the number of sections. So we made an equation to represent the structure of the relationship. Total length is generated by the length of each section multiplied by the number of them. This led to the calculation total length equals section length by the number of sections. That's how we got our 14 meters. Each stage is brief, only 3 lines. There's a clear logical link between the stages. It's the relevance of value generated by the previous calculation that lets us move into the next calculation. There are many possible visual representations of the problem-solving process used here. we'll consider a couple. They're both saying the same thing, but with a different emphasis. Here's the first. This diagram emphasizes the tactical nature of the sequence of focus activities. It addresses the question, what action can I do in order to be successful on this part? So we have our original problem. How long a fence can I get for $950? The first part calculates how much of the $950 is associated with the length of the fence, and that was 700. Then we looked at how many sections of fence will the $700 allow, and we found it was 7. And then we converted the 7 sections of fence into what length of fence does that mean? 7 sections, 2 meters each. So our final solution was 14 meters. So the calculation has taken us from $950 available to 14 meters of fence produced. In the real world, each section of that type of process is given to a different person, someone who is an expert in that particular field. So one person would do this, another person would be in charge of this, and a third person would then have the processing passed on to them, and they would finish. On the other hand, the vertical arrow in the next diagram emphasizes strategic management, where the process towards the long-term goal is kept dominant. The responsibility for this organisational aspect is given to one person who oversees all processes. Here we have the problem. One person is responsible for making sure we get a satisfactory solution. That person assigns the different stages to different people. While a strategic operator is aware of the finer details, their working in an early stage simply prepares the way into the next stage. Strategic thinkers address the fact that steps link a vision of the future to an eventual reality. While a strategic operator is aware of the finer details, that's the person represented by the large vertical arrow, their working in an early stage is simply to prepare the way into the next one. Strategic thinkers address the fact that steps link a vision of the future to an eventual reality. Strategic thinking emphasizes proactive strategies, which allow leaders to notice opportunities for successful action in realistic timeframes. Strategic thinking provides the ability to understand the whole task. If a construction site requires electric cabling, then the foreman will get an electrician. In this role, the foreman is thinking strategically. They understand enough about electrical work and what the job requires to ensure they retain responsibility. The technically proficient electrician actually does the electrical work. He has the tactical responsibility to supply quality workmanship. This strategic tactical division applies in construction industries as shown in the diagram. The foreman has the strategic management. Other people, carpenters, plumbers, electricians, have tactical expertise, and the two groups work together to give a successful result. The most important benefit from learning mathematics is understanding what influences decisions taken during the solution process. Strategic thinking makes a student more sensitive to input, which requires processing. It ensures they understand the problem. Strategic thinking engages in analysis, interpretation, and evaluation. You see what is new and you relate it to what is old. This leads to accuracy by applying previous experience. Strategic decisions set into motion a string of sequential but closely linked events. These are based upon pre-planned responses to possible subsequent steps. Note the mention of pre-planned. Looking ahead. Strategic thinking generates design which is modular and able to be tailored to circumstances. It identifies the context of the problem, the underlying structure of the problem, and the relevance of data. These characteristics ensure consistent actions. Strategic considerations get to the result. Tactical considerations determine its quality. Communication between the two types of special skills provides ongoing feedback, allows coordination, and it monitors progress. So in the diagram we have the strategic manager communicates with the tactical experts. End result is that between the problem and the solution you have a lot of back and forward communication to make sure everything is going well. Some things to consider are strategic coordination is associated with general knowledge, overview, wide experience, big picture thinking, linking other people thinking ahead and making sure what's being done is relevant. On the other hand, production on the basis of tactical expertise, that's associated with skill, eye for detail, being focused on the task in hand, being self-contained, having good reflex responses, critical actions, and avoiding distractions. This ensures the job gets done, and this ensures the quality of that job. People usually specialise in either strategic or tactical structures. To be successful at maths, a student must develop skills in both. Each mathematical solution calls on the student to use strategic thinking to coordinate the application of their own tactical skills. Having poor skills guarantees an unacceptable result. Poor coordination of good skills means limited progress towards a solution. You have to know what to do and do it at the appropriate time. So what does a mathematics student have to learn in order to be successful in the subject? The simplest answer is surprisingly little. Firstly, they need a small set of number manipulating actions. Secondly, they need an awareness that tactical actions apply in a sequence. And thirdly, they need a set of strategic problem-solving steps to make sure that tactical actions are applied appropriately. Most importantly, a student must realise that the number crunching stage is simply one of the focus aspects. To summarise all this, let's look at the carpenter problem again. How long a fence can I get for $950? First task, turn the $950 for the job into the amount of money for the fence. Then turn that amount of money for the length of the fence into the sections, which are the units by which the length is judged. And once we know that there are 7 sections, we turn that number of sections into a distance. So from the problem to the solution, here we had 3 different processes to coordinate. Firstly, secondly, thirdly. They had to be done in that sequence, and an error in any of them would lead to the wrong solution. Strategically, knowing where we're going, tactically, being able to do the calculation correctly at each stage. So we have tactical thinking. Can you solve an equation? Yes, we can. We shift and reverse processes. Strategic. How does that relate to the solution? It gets me to the next step and I know what to expect to do with it. Organising calculations like the one shown can cause a thinking overload. It's still a lot of work and that makes it very difficult. While strategic thinking helps us organise our calculation and gets us to a solution, when it's applied early, it can often reveal a simpler alternative approach. We will develop this idea of strategic thinking as it applies to mathematics in more detail in later lessons. It's the main concept that allows us to simplify the subject. In other words, it makes maths light. So I'll see you in the next lesson where we apply what we've done today. See you then.